Well, hello, Seven Blue. It is so nice to be with you. We are, for our last lesson, going to revisit an idea that we had explored before the world shut down on us. And it's called rationalizing the denominator. I hope you relish each and every moment of you taking notes. I'm not sure what the expectation for you will be next year. I hope they do make you take notes, but you got to do it now. So let's start with this statement. The denominator cannot end as an irrational number. And we've had some good experiences with irrational numbers. Generally, what we're talking about here is non-perfect square rads. Yeah. So it wasn't too long ago that I actually pointed out we were looking at this. We were dealing with sine, cosine, and tangent, and we plugged this into the calculator to get a certain answer. However, if this was an end answer, if you will, let's say we had done some work beforehand and we ended up here, you simply couldn't box this up because there's something called rationalizing the denominator, which I love that name. It's so cool because what we're going to do is we're going to ensure that our denominator doesn't end as an irrational number. How do we do that? By rationalizing it. And so what we need to think about is kind of early thoughts about using a fractional form equal to 1. That's something that's been a big kind of guiding principle throughout our math life. And in this case, what I would do is I would multiply this expression because I can't change its value. That's why I have to multiply it by something equal to 1. And in this case, I'm going to go rad 3 over rad 3, which would obviously be equal to 1. Now on the top, what I'd be multiplying obviously is 1 times rad 3, which is just simply rad 3. And then on the bottom, rad 3 times rad 3, we know to be rad 9. But that can be simplified further. So I'd say the numerator is rad 3, and then the square root of 9, or rad 9, is simply equal to 3. And now that my denominator is no longer irrational, I can box that up. There is no concern about numerators being irrational. That's just fine. It's the when the denominator is irrational. Okay, let's look at another example. So I have 4 over rad 12, and there's actually a couple of things you could do, but if all we were focused on right now is rationalizing the denominator, one choice we could make is, remembering that we must multiply this by a fractional form equal to 1, is we could simply multiply it by rad 12 over rad 12. And in that case, what I'd get on the top is 4 times rad 12. Remember that we can't make that anything different than it is. And then rad 12 times rad 12 is clearly rad 144. Now, there's still more simplification to be done, because if you think about this 4 rad 12, well, rad 12 has a perfect square in it, so I could call that rad 4 times 3. We'll deal with that in a moment. Clearly, the square root of 144 is 12. Now, again, I have some simplification with this 4 and this 12, that 4 becoming a 1 and this 12 becoming a 3. And then remember, I have to focus on, I've got rad 4. I know what that is. The square root of 4 is 2. 2 rad 3 over, don't forget the 3 that the 12 once was. And this thing cannot be further simplified. This thing could be boxed up. Now, not always do I make the choice. Sometimes in talking about this, I talk about, or some other intelligent choice. Because moving from rad 12 all the way up to another rad 12 is going to kind of make things bigger and more simplification necessary. However, if I was going to go a different route on this, instead of multiplying it by rad 12 over rad 12, if you notice, there is a perfect square along the way. And if I had multiplied this by rad 3 over rad 3 instead, what I would get on the top is clearly 4 rad 3. And on the bottom, I'd get what? Well, rad 12 times rad 3 is rad 36, which is something I know to simplify. So I could say, okay, so there's going to be 4 rad 3 over 6. Now, is there more simplification? There is. I'd have to do this 2 and this 3. But you'll see as you move forward in this, again, this is an algebra concept that often does involve variables and stuff like that. But we don't always just simply multiply by whatever the denominator is in rad form. We might make other choices, as you saw I do in that second time around. Hey, let's draw this up. So this should look familiar to you, and you should know by the symbols that I've given you that this is a special type of right triangle. In that those two legs are congruent, we know that this would be a 45, 45, 90 right triangle. And again, I've encouraged you to just kind of memorize this sort of thing, that if this was x, and this would be x rad 2. So I'm going to draw another 45, 45, 90. In this case, we actually know the values. The hypotenuse, okay, well, I'm telling you it's 45, 45, 90. The hypotenuse is 1. What would that make my two legs? So if you think about it, generally, like, this is the same form. But if my hypotenuse is 1, what would that make my two short legs, or no, two legs? Yeah, if you're thinking, it would have to be 1 over rad 2, 1 over rad 2. And if they asked me to express the length of one of the legs, expressing it as 1 over rad 2 is not okay. Why? Well, because rad 2 is irrational. And so in order to rationalize the denominator, what I would do is I'd say, okay, 1 over rad 2 times, and I go rad 2 over rad 2, and then clearly 1 times rad 2 is rad 2. And then rad 2 times rad 2, we know will be rad 4, which I don't mind if people go directly to this being over, so because it's going to end up being 2. And that I could box up. So I don't have a problem when we don't really show that rad 4 and then it becoming 2. But, whether I have a problem with it doesn't matter much because I'm not going to be your teacher that much longer. So what I'm going to ask you to do, and just kind of reviewing the 2 models, or 3 models really that we did, I want you to try this on your own. Now, these are actually models from your book. So if you're looking at your book, just close it up. I want you to do this on your own. I want you to do 3 of them. It is normal, like a try this. I'm going to ask you to pause and then come back when you think you've come down to the most simplified answers. So again, you're doing all 3 of these. You're going to pause and come back when you're done. 1, 2, 3, pause. And hi, you're back. So here are my choices. I multiplied this one by rad 5 over rad 5. I know that does become 3 rad 5 over rad 25. However, I wouldn't mind going from the orange step there simply to 3 rad 5 over 5. That is fully simplified and can be boxed up. This next one I multiplied by rad 3 over rad 3. That gave me 6 rad 3 over what is essentially going to be 3. Now there's more simplification with this 3 and the 6, the cancellation happening and me ending up at 2 rad 3, which is as simplified as it can be. And then the last, I multiplied by rad 2 over rad 2, giving me, obviously, rad 3 times rad 2 is rad 6, over rad 2 times rad 2 will ultimately become 2. And you might go, oh, is there more simplification? No. Rad 6 doesn't have a perfect square factor in it, so that's what I end up boxing. And I boxed it with a color I never use. So I guess the last thing is this. Congrats. Thank you. I appreciate all the experiences we had. I've grown to care about each and every one of you deeply. I am saddened that our end of our school year was closed out, but, in some ways I do believe that God has a plan. And, it forced me to create videos I never would have created. It forced me to ensure that I was more responsible and organized than I had to have been before. And it forced me to really reflect on things and reflect on where I was in life and what I needed to do. None of my decisions in regards to leaving have to do with you. In fact, you as a class, the 7th grade class, you were my biggest draw to stay. I will miss each and every one of you. I am available to you, as I said in the past. And if you ever need me for any reason, you should reach out. I congratulate you so much. And you might think, oh, this is it. I'm done. Well, no. One last homework, but I want you to relish in the gift of Saxon. I think Saxon has done so much in creating a mass superhero that you are. And this is the last 25 problems they have to offer you. You will likely not be using Saxon anymore as you move forward. But you will be so far ahead of your peers when you meet them in high school because you've been exposed to so much math. We never did homework 115, so if you're like, I'm so bored in life, well, you could always do homework 115. However, we are going to need your books back at some point. Thank you, thank you, thank you. I love each and every one of you, and I will miss you terribly. I'm officially assigning HW120, and take good care. Bye.